Welcome to problem solving exercises video. In this video, we will solve a profit maximization exercise given the demand function instead of inverse demand function. So let's have the demand function given by Q equal to 100 minus 0.5p. This is the demand function. We are also given that the total cost for producing output Q is equal to 0.5 Q square plus 25. So we can see there is a fixed cost of 25. And so given the demand function, I need to write it as a price times quantity for obtaining the total revenue, P times Q. However, we notice here Q is given as a function of P. What I need is the inverse demand function given price being a function of quantity. So let's change the demand function to inverse demand function. I have Q equal to 100 minus 0.5p. I need P on the left hand side, Q on the right hand side. So I can add 0.5p to both sides. And then I don't need Q on the left, so I subtract minus Q from both sides. Given this, I am able to find out the inverse demand function in one more step. So I have Q and minus Q cancel out, minus 0.5p plus 0.5p cancel out. So I have 0.5p on the left hand side by itself. And I have 100 minus Q on the right hand side. Then I go further. I need P by itself. So I divide each term on both sides by 0.5. So I get P by itself. 100 divided by 0.5 is 200 minus Q divided by 0.5 is 2Q. So this is our inverse demand function given the demand function at hand. Now I can find out the total revenue being price times quantity. P is 200 minus 2Q times quantity. I can simplify it by multiplying Q to each term in the parenthesis. Turns out to be 200Q minus 2Q square. Having found out the total revenue, now we are ready to find the profit. Total revenue minus total cost, 200Q minus 2Q square. That's my total revenue minus total cost. I will first write it in the parenthesis, so 0.5Q square plus 25, and then we will simplify the term. So I have 200Q minus 2Q square. I have negative in front of the parenthesis, so if I remove the parenthesis, each term sign will be reversed. So this is, if there is no sign here, it is positive, so positive will become negative. So minus 0.5Q square minus times plus is minus 25. So my profit turns out to be 200Q minus, this is 2Q square, this is 0.5Q square, turns out to be 2.5Q square minus 25. Now this is the objective function which we want to maximize. So let me write it formally. Maximize profit, which is a function of Q, 200Q minus 2.5 q square minus 25, and I want to choose quantity non-negative. So in this setting, our objective function is pi as a function of q, 200q minus 2.5 q square minus 25, and my choice variable is q, which I want to be strictly positive. Then we will again, I want to apply the first order condition, for which I will write the statement: if profit as a function of q attains its maximum at q star positive, then at q star the first order condition will hold. So let me write down the first order condition. FOC, derivative of profit with respect to q. The first term is 200q, so the derivative is 200, minus the second term is 2.5q square, so 2.5 times 2 times q to the power 2 minus 1, and then the third term is a constant, so the derivative is 0. And then this must be equal to 0, that is our first order condition. So let me rewrite 200 minus 5q equal to 0. I want to solve this. So I take the negative 5q to the right hand side, becomes positive. I can divide both sides by 5. So I got q star turns out to be 200 over 5, which is 40. So this firm will sell 40 units. Let's find out the profit. So first I will find out the price, which is 200 minus 2q. So 200 minus 2 times 40, 200 minus 80, price turns out to be $120. So with this, I can now find out the total revenue, price times quantity, 120 times 40 turns out to be $4,800. We also know the total cost. It is 0.5 q square plus 25. So 0.5 times square of 40 plus 25. I can simplify 0.5 times 1600, that is square of 40 plus 25. Half of 1600 is 800 plus 25. The total cost turns out to be 825. Now we know the revenue, we know the cost, the profit. Here the maximum profit is 4,800 minus 825 turns out to be $3,975. So that's our solution. Q star 40, P star 120, and profit star 3975. And this is a good point to stop.